Let us now discuss this question. Find all distant indices in an array. So, what is given in this? You are given a zero indexed integer array nums and two integers key and k. So, we are given with an array nums and also two integers key and also k. Now, a k distant index is an index I of nums for which there exists at least one index j such that the absolute difference of I and j is less than or equal to k and nums of j equal to k. So what they mean is we have some keys here and somewhere, right? This is my I. Now this will be the j and j minus I, the absolute difference should be less than or equal to k. So what are the indices? This is an index which is called K distant index. So, what are the K distant indices sorted in increasing order? So, we need to return a list of all K distant indices sorted in increasing order. Now, if I got an I here and I got a key, like this is my J, right? This is my key and this is my wait a second. So this is my key and this is my J. Now, right? So the difference between these two, the difference which is the absolute difference is less than or equal to k. So then only this will be called as k distant integer. But if it is not less than or equal to k, then we don't call it as a distant k distant integer, so we don't need to push that back into our answer array. So we don't need to consider it. Now, I think you have understood what the problem states. Now, let us go and look at this example 349139 and k is equal to 9, k is equal to 1. So, I have 3 and 9. So, the distance between these two is 2, right? So if I give the indices, then 0, 1, 2, 3, 4, 5, 6. The distance between these two, absolute difference is 2. So we don't need to push this index 0 into our answer. This index 0 into our answer. So let us define an answer array, right? Now, let me go to this index 1 and the key, the nearest key. Why should I go to the farthest key when I need the difference, absolute difference should be less than or equal to k. Now, so the difference between these two is just 1, which is less than or equal to k. So what I'll do is push this index 1 into our answer. Now, let us go and check for the next index 9. Now, I have the index at 2 and the key also is at 2. Now 2 minus 2 is 0, which is less than or equal to k. So I would get this 2 into our answer array. Now I have gone to 1. That means index 1, right? The difference between these two is 1. So I would push this into, right, this index 3 into our answer array. Now I have 4, right? Now when I got 4, the distance between these two is 2, but there is another key which is having a distance of 1. So which is less than or equal to k. So what I'll do, I'll just push this index I. Now the next thing again, I got a 9 here which is equal to key. So 5 minus 5 is 0. So which is less than or equal to k. What I'll do is just push this 5 into our answer. Now I got this again 6 at the 6. Now I have this distance as less than or equal to k. That means the distance is 1. So I'll push this back into our answer array. Right. Now if you see, do I need to only check this? I can also check this 9 at the first. So what I'll do is I will check each and every index where key is present, where key is present. If the index and I has an absolute difference less than or equal to k, then this I is k distant integer. I'll push that back. I'll push this I back into our answer array. Now, this is my intuition. I'll write algorithm soon, but let us see. Let us see here, and key is equal to 2 and k is also equal to 2. So key is equal to 2, which is nothing but all the elements are 2, and I have the key as itself, right? So let us see at this time 0 minus 0. The index is 0 and I got a key at 0 itself. So 0 minus 0 is 0, which is less than or equal to k. Right? Answer is equal to I got 0. Now, I'll go to 1 and the first time I got here is at a distance of 1, which is less than or equal to k. So what I'll do, I'll just push this index back. Now I got 2, right? So what I'll do, I'll check here at 0. Now the distance is 2, which is less than or equal to k. So 2 will also be pushed back. Now I have 3. 3 minus 0 is 3, right? The absolute difference is 3, right? Now what I'll do, I will be having all the indices, right? 3 minus 1 is 2 now. So what I'll do, I'll just push this back, this index back into our answer. Now I have 4. So I'll check at 0. 4 minus 0 is giving me 4, which is greater than k. So again, 1. 4 minus 1 is giving me 3. No. 4 minus 2 is giving me 2. So this index 4 is pushed back into our answer array and return this answer array at the end. Now, to know these keys, where I got these keys, I will initialize a vector of int. Let me write the algorithm. So I will store in a vector of int the indices. Let me name it as key indices. So I will go through every index for I is equal to 0 till n. If nums of I is equal to key, then key indices dot pushback, key indices dot pushback I, right? So I got the all indices where I got a key. Now I need to go to every index, but before that, let me initialize our answer vector which I need to return for I is equal to 0 till n. I will go through every index j is equal to 0 till n, but I can write it as for int I also got a j, right? I am getting the j, nothing but j is nothing but going through every element in key indices. I am going through every element in key indices. So when I go like this, only if j minus I, if the absolute difference of I minus j is less than or equal to k, then only push this back into our answer. Push I back into our answer. Push back into our answer. Now, this, right, I might get two indices, right? When I got this index right here, for this, I got, let us see that for this, I got at here, I got an index. Again, I got at this will be satisfied. What I need to say is, what I mean to say is, I have like this. Now, I'm at this index. Now, this index will be true as this index and this index, these two difference is less than or equal to k. Now when I go here, it is also giving me a difference of less than or equal to k. So this will also be pushed back into our answer. So for one index, I am pushing this I for two times for two valid indices, for two valid j indices. So what I'll do, I'll just break if if this condition satisfies for one time. Now after that, as this said, to sort in increasing order, I will sort the answer array. Sort answer dot begin, comma, answer dot end, right? And return the answer at the end. Now let us do the code for this. Let me initialize int n is equal to dumps dot size. Now I am initializing this key indices, right? Key indices. Now for int I is equal to 0, I is less than n I plus plus. If nums of I is equal to key, then key indices dot push back, wait a second, push back I. Now I need to initialize an answer vector for vector int answer. For int I is equal to 0, I is less than n I plus plus. For int j in key indices, if absolute difference of I and j is less than or equal to k, then what I'll do, answer dot push back, push back, wait, push back I and break here itself. Now after that, let us sort this indices, right? Sort answer dot begin, answer dot end, right? Return answer at the end. I think you don't need to write this sort function because we are just pushing that back in ascending order. Nothing but I am just pushing this I one after the other in a sorted order. So this is how you solve this problem. And if you like this explanation, do share to your friends and do like to my video and do subscribe. And if you have any suggestions or any queries about the question, or if you need any other problem to be solved or explained in this channel, please comment in the comment section. Thank you.